Because ALMA is really four pieces. It's an institute in North America. It's the European Southern Observatory in Europe, a very large institute. It's the National Astronomy Observatory in Japan, and then it's the joint ALMA Observatory here in Chile. Getting the four pieces to work together effectively and efficiently is a very interesting challenge, because everybody has their own, what they imagine to be the highest priority at any given moment. And I think keeping everybody working really well together in striving to make ALMA as good as it can be, I think is one of the more important challenges. I wouldn't say it's necessarily the biggest challenge, but it's probably the most important challenge, keeping all the parts working together very well. And what's really fun in that challenge is that there are a lot of really good people in the four locations who contribute to running ALMA. So even though it may be hard work at times to make things work as smoothly as possible, the outcomes are inevitably fantastic.
So GEMS, it's a one-of-a-kind system in the world right now, and it should be for a few more years. It's a Gemini's MCIO system, multi-conjugated adaptive optic system. Basically, we use a laser to do a fake constellation in the sky, and taking images of that fake constellation, we're able to compensate the aberrations in the atmosphere in real time. And there are other telescopes that they use the same system, but they use a star. We're still the only ones that have that constellation, the 5-star constellation. So when I started working at Gemini, it was initially to support that project, because it was a huge amount of work that was necessary and they needed more electronic support. But then in time, I started getting more and more into that system, and eventually I became the engineer in charge of the system.
Basically, the problem originated when we found that the universe is accelerating in its expansion. Dark energy camera is a product of a search that we're looking for a cosmological problem. So there was a big rush based on this keyword called dark energy. And so to gain an insight as to what the effects of dark energy is, because we can't touch, feel, smell, or even use dark energy at the moment, what we have to do is to sample many objects, mainly supernova, and to gain distance scales, and objects to find and to put them into perspective of how they're moving from each other. Now this takes, of course, a large portion of the sky. So the concept of the dark energy camera, which makes it special, is that we take a series of photographs, or frames as we call them, of the sky each night in, I think it's 5 different filter bands, which means 5 different colors. And all of those by themselves are marvelous images. They are huge images. But it's not enough. You can't discover dark energy or the effects of dark energy in just one frame. So it's going to take something like about 6 years, 7 years, 8 years of data to be able to filter out all the artifacts which there are and become precise enough to define what's happening in the universe according to the effect of dark energy. So the dark energy camera is big. It has a very wide field of view. And it also is very effective at doing survey on the sky at large swaths of sky.
So there are exciting things. We are now or are going to have instruments that are going to be able to study. Well, the most important problem is astronomy, dark energy, dark matter, origin of galaxies and how they form. So we have possibility of getting data to study all these things, and it's exciting time. So if you like the astronomy, go ahead and do it, because it's fun.